There are two different types of maps that game artists use, normal maps and height maps. And at first glance it might seem like there are two different ways of doing the same thing, but while they both give our low poly models more apparent detail, they are used for distinctly different purposes and are not interchangeable. Height maps are black and white because they only care about the height difference in the direction perpendicular to a face. Black is down, white is up, and 0.5 gray is no change in height whatsoever. When we bake these cubes as seen from above using a height map, we can tell exactly which ones are farther away. Normal maps are kind of the exact opposite of height maps. They don't contain any height information whatsoever. Instead, they contain angle information. They're colorful because each color records which way the faces are pointing. When we bake these cubes like we did with the height map, we will see the angles of the beveled edges, but they all appear the exact same height, since again, there's no height information. The results from this simple test might make it seem like height maps are the way to go, but there's one massive advantage that normal maps have, which is what makes them so useful in games. We can use the angle information to make sharp edges look soft by angling faces in opposite directions at the edges, which is impossible to do with a height map that only records up and down values. Giving hard edges the appearance of beveled edges drastically increases the quality of the model as seen in-game, because it allows the light to glance off edges in a really pleasing way, which in turn makes it so that we can better tell the form of the object when seen from a distance. To make things complicated, there are three types of normal maps: tangent space, object space, and world space. Tangent space are the most common type, and records which direction the details are pointing in relation to each individual face. Blue is looking at the face dead on, red is looking from the right, and green is looking from the top if you're using OpenGL, or from the bottom if you're using DirectX. Object space takes the local orientation into account, so each side of the object is a different color. For some reason this is faster for graphics cards to compute, but it does have some drawbacks. If you have a character that deforms, it's going to throw everything off because when they twist around, all of the shading will be backwards. Another drawback is that you can't mirror UVs because each side is different. So it might make sense for some super basic objects, but it's very rare that I'll use object space. World space is exactly like object space except in relation to the world. So instead of right and left relative to the object, it's like an absolute east and west that doesn't change when the object rotates. So essentially if your object rotates at all, this type of mapping isn't going to work. You might find it useful in some very specific programs like Substance Painter, but in general you wouldn't really use this in a game engine unless everything is completely static. I know the topic of normal maps can be a bit confusing at first, so hopefully this video helped to clear things up. If you do want to get a bit more in-depth, check out my Intro to Normal Map Modeling for Games course using the link below, where we'll cover everything you'll need to know about modeling and baking high poly normals onto low poly game assets. Hope to see you there!